from GLERL. And there's a whole lot of things that I won't be presenting, so if there's something that you think that we might do or know that we do and you want information on it, just get a hold of me and I'll try to accommodate you and find what you need. Just briefly, some quick background on the program. This is work that's been done as part of various projects going back to the 1980s, and the purpose of those has always been to observe and to understand the lower food web. The work's focused mainly in the Muskegon Grand Haven area. And right now, it's focused along a nearshore to offshore transect with stations at 15, 45, and 110 meters. That's like a nearshore, transitional, and an offshore zone. We sample, it's based on getting a good idea of temporal variation, so we do high frequency sampling. We have moored instrumentation, and then we also do actual sampling roughly twice a month from March through December, as long as we can get out. It doesn't take too much memory to go back to last winter. We all know what an awful winter that was, and so I probably don't need to tell you that. But we have offshore thermistor strings, and that can show you just what those water temperatures were like last winter. This is at that 110 meter station about 30 meters down. And you can see this would be your period February, March, even into April, where we were just above freezing 10 meters down in the lake. We couldn't get to that mooring in April when we usually pull them out. When we pulled it out in early May, the temperatures weren't even 2 degrees yet. We were out earlier this week at that offshore station. The temperatures are 2 degrees there right now. So it was obviously a very cold winter, and this just gives you a sense of that. And that had an influence, especially in the offshore region, on the lower food web last year. And it wasn't that long ago we had a winter where the lake barely destratified out there in the offshore. So it's been a really variable in terms of the thermal environment. Obviously, another big factor in the lower food web has been the arrival and expansion of quagga mussels. Tom Nalepa had a technical report that came out this past year. If you're interested in looking at that, this is a chart from that technical report looking at the quagga mussel biomass from the lake-wide surveys. And you can see that in 2010, the latest year for that survey, there's kind of this ring in what we call that transitional zone, that mid-depth zone. And that's that ring of mussels that's really starving the offshore. And this survey, this lake-wide survey, will be taking place again in 2015, so we'll be able to update that once those are counted and measured. A little more recent idea of what's going on with the mussels. We can look at some of the data from our Muskegon transect. We have some nearshore data, and this in the nearshore, especially on that side of the lake, it's a really unstable, variable habitat. And you can see it's really kind of hard to see what the mussels are doing there. It's quite variable. This is based on sampling 3 times during the year. If we look at this transitional zone, which is kind of that hot spot for mussels, it really looks like, based on over the last 5 years, we're starting to decline, where the mussel biomass has been trending downward at that site. And so that's good news. The other thing that's interesting is at this offshore site, this was in 2009, was really dominated by small mussels. And so we expected that biomass to steadily increase, but we haven't seen that. And that biomass has remained pretty low and fairly stable. So it's good news that that hasn't been increasing. One of the reasons it hasn't been increasing is because in 2009, it was mostly small mussels. And last year, that population, it really hasn't changed. It's still mostly small mussels. And we don't know if that's because those mussels that settle there just aren't growing, just because it's an unproductive and cold environment, or if they're not surviving. It's really difficult to differentiate that. But the end of it is that mussel population is not, the biomass really isn't increasing because it's still a small mussel population. If you contrast that to that 45 meter station, where you can see it's advanced to more older mussels, larger mussels there, and there's very, very few small mussels recruiting in there at that 45 meter station. So that's good news. That's why we think that population's stabilizing, and we may be on the downward trend in that area where mussel biomass has been highest. One thing that did happen this year is we saw a lot of veligers though, and we're not real sure if veliger numbers mean anything in terms of mussel numbers, although we should have a good idea next year. But at all these sites, we've been seeing low numbers of veligers in the water column, and then we had relatively high numbers, especially at that 45 meter site. So if A lot of veligers mean you end up with a lot of mussels. We'll have a better idea about that next year. So it's unfortunate we see increase in veligers last year. Next, looking at some of the water quality data. This is from the nearshore site in 15 meters, and that is quite a variable site. So I'll show all the data for the last 8 years. This is phosphorus and chlorophyll. Last year we had that big shot of phosphorus that came in with all the flooding that we had in the region. We didn't see that this year. Part of that may be is we couldn't get onto the lake until the end of April, so it's possible we missed that. Looking at chlorophyll though, it's fairly high, but really no trend. But it was as high as it was in 2013 when we had all that flooding. Typically in that nearshore region you have relatively high phosphorus or chlorophyll in the spring, and then it kind of drops out later in the year. This past year we revisited a transect of five stations between Muskegon and Grand Haven in the nearshore region that had been done in the past. And this is just to kind of give you an idea of just how much phosphorus and chlorophyll have changed over basically the last almost 20 years. Looking at the phosphorus, and this station is right off the mouth of the Grand River. So this is where it's a really unstable station to sample, but this is where you're getting your big shots from the Grand River, which is a huge influence on the phosphorus in the whole lake. In 1996, when we sampled there, you can see phosphorus is fairly high in the spring, really almost all through the summer, then it drops out. Much, much lower in 2014, where you get a shot in the spring. This is a bump up again in December. I think that's related to we had a lot of snow in November and it all melted in December, so I think that's what we caught there with the phosphorus. But a huge difference in the amount of phosphorus over that 18 years between 96 and last year. And you see basically the same thing with chlorophyll without that spike in December. And we'll be revisiting that nearshore transect just to get an idea of what's going on in that nearshore area, especially since the Grand is so important to nutrient loading to the whole lake. Going to the offshore, this is in the spring, during April and May, when historically you would have had a spring chlorophyll bloom. Looking at, and these lines are the averages for each of those time periods. If you just broke it up into 2 time periods. And you can see the phosphorus has declined and the chlorophyll has declined even more than the phosphorus. And to have steeper chlorophyll declines than phosphorus is indicative of a mussel population impact. And really not a whole lot going on in 2014 that's very noticeable relative to the past 8 years in that latest time series. Certainly there has been no return of the spring diatom bloom, the spring bloom right there. And chlorophyll's been pretty much the same for the last few years. Things get a little bit more complicated when you move to the summer because you're mixed. This is the surface mixed layer. You can see it's a little bit more noisy, kind of a trend for the average chlorophyll to have decreased over time. 2014 was a little bit lower than in the more recent years, but it's a more noisy data set than that spring data set is. If we look at the other thing that we've seen in the offshore in the summer is we saw a loss of the deep chlorophyll layer. We define that as the area under the curve that's over 2 micrograms per liter, where we didn't have a deep chlorophyll layer. We saw a return of that last year. We think that's related to that phosphorus loading in the spring. This year didn't decline to these levels, but it did decline relative to 2013. Part of that also this past year is the deep chlorophyll layer got a late start getting set up. Usually the deep chlorophyll layer is largest in June and July. It's starting to decline in August. If we looked at July and August, it would maybe have been a little bit larger, but because everything was kind of set back because of the cold temperatures, it really didn't set up very well in June like it typically should have. We can look at some nutrient limitation indices. One is the carbon to phosphorus molar ratio, or the carbon to chlorophyll ratio. And this is for the near shore in the spring and summer, and then the offshore in the spring, and then the offshore surface mix layer and the offshore summer deep chlorophyll layer. The trends here are you tend to be less nutrient limited in the spring, which is not surprising. whether you're in the nearshore or the offshore. And the nearshore tends to be less nutrient limited than the offshore. None of this should be surprising, but this just adds some data to show how that is. Our worst ratio, or the most nutrient deprived, was the surface mixed layer in the summer in the offshore. And then just an idea of what the phytoplankton are that are out there. These are virtual phytoplankton. We haven't verified these yet, but they're from a fluoroprobe, so it's measuring wavelengths. But it was mostly both in the near shore, spring and summer, and in the offshore was green algae and diatoms. This is a little bit of a change from what we'd seen the previous few years when there was a substantial amount of blue-greens as well. And you can see that deep chlorophyll layer was almost exclusively diatoms, which is what it should be, so that's good news. Next, we'll move into some of the zooplankton data. This is from that nearshore site, and this is the mean annual abundance over the whole year. And you can see that it really isn't that different from the earliest part of this data goes to 1998. And it really isn't that much different over the last 8 years than it was then. No big signal in 2014 compared to these previous few years. The population is mostly calanoids and bosmina, a small clitoris in that nearshore area, but not a big signal like we'll see a little bit in the offshore. Looking at the predatory clitoris, because these can be a major predator on zooplankton, potentially competing with fish. In the nearshore region, you get kind of a mix of predatory clitoris. In the spring, you have Copepods and maybe Leptodora. And then late in the fall, you get Pithotrephes, but because they're so much bigger, they sort of swamp out and show up as a major part of the mean annual biomass. And we had relatively high biomass in 2014 of predatory clitoris in the nearshore area. Looking at the offshore, you can see there's been declines since in zooplankton biomass since the late 80s, early 90s, although the biomass isn't really all that different maybe from the late 90s. But you can see 2014, very, very low biomass of zooplankton. And then what we see is we have almost no clitoris. Almost all just calanoid copepods, general calanoids, and then limnocalanus, which is a large calanoid we separate out. But very, very low biomass of zooplankton. We think this is a temperature effect. I'll show that in a little bit. Just looking at a couple groups, pulling out some of the groups other than the calanoids, which tend to swamp everything. Cyclopoid copepods had been making a comeback, which we weren't real sure why, but they had low numbers this past year. Limnocalanus have been pretty stable over the last 5 or 6 years. With the cold weather, you would expect them to do fairly well, so they didn't really go down. They didn't go up either. They're lower than they had been in the late 80s. Daphnia, like cyclopoids, had been making a comeback relative to these low numbers, and there's very low numbers last year. This is to show you kind of why we think the temperature is driving these low numbers. 2013, you see where something like Daphnia, they'll show up in the early summer, in late June, July, and they'll peak in September, around there, and then drop off into the fall. Last year, we didn't even see Daphnia in our net tows until almost September. And then their numbers, they just didn't have time to go up before it got cold again. So the peak numbers were in October last year. So they just didn't have a chance. It was so cold offshore, whereas in the nearshore, it warms up relatively fast, even when it was so cold. Looking at predatory clitoris, in the offshore, the predatory clitoris population is completely dominated by Pithotrephes. There's very few of the other predatory clitoris, some Leptodora, almost no Copepods out there. We had seen huge numbers in 2007, 2008. They dropped out. They were kind of steadily increasing, but then real low numbers again last year. And that shouldn't be a surprise, they're clitoris, right? So it's pretty much the same thing as what we saw with the Daphnia. Something like a Pithotrephes usually shows up in June. Their numbers aren't real high, but by late summer and all the way through the fall, their numbers will be high. Last year we didn't see them until August, and they just never really got going. They just didn't have a chance. It was too cold in the spring into the early summer for these clitoris to really get strong populations this past year. So the phenology was just set back because it was so cold, and then by the time they got going, it was fall, and they didn't have a chance to get going. Finally, looking at mysis, this is the mean annual biomass. We took the size of the mysis into account this year and turned it into a biomass. At this mid-depth station, there's almost no mysis anymore at that 45-meter site. So basically, we just sample that anymore just to confirm that there's very few mysis in that region. You know, there had been mysis, you know, in the late 90s in that shallower depth zone. It's probably, in some sense, there's just too much light there. It would be one of the big factors there with the clearer water limiting mysis. They're very light sensitive at that shallow depth. But it's not like they've moved offshore and we have higher numbers offshore. You can see relative to the late 90s, the numbers are fairly low. 2014, they didn't really go up or down from the last few years, but they're certainly on the low end compared over that 8 years right there. The interesting thing is the numbers, or the biomass of mysis right here, right now, isn't all that different from what you would have seen in the 1980s in this region. But in the 1980s, those numbers were depressed because of all the bloaters in the lake, so they were under heavy top-down pressures right now. So these numbers aren't depressed right now because of heavy predation from bloaters, probably because that bloater population is nowhere near what you would have had in the late 80s, early 90s. So mysis are holding their own, but they're certainly on the lower end of what they have been in the past. And I think that's it.